We're going to be doing the same thing we did in the last video, but this time without a calculator. So, for the cubic function y is equal to x to the 3 minus 6x squared plus 9x plus 20, determine the maximum and minimum values for minus 1 less than or equal to x less than or equal to 4. Alrighty, so this is our function. What do we need to do? We need to see where is its stationary points, in particular its minimums and its maximums, and then check the borderlines to make sure that those are not maximums or minimums as well. So we're looking for stationary points, which means when dy dx is equal to 0. And in this case, dy dx, the function itself is 3x squared minus 12x plus 9. Alrighty, so there's our function, and we're looking for when that is equal to 0. So we'll set dy dx equal to 0. And at this point, you can see that we're going to have a quadratic, and we're going to be solving for it. So first of all, let's factorize out the 3. And then let us do a quick t-chart to factorize the rest. The only solution is minus 3 minus 1, and we can finish the factorization as it is a monic equation after factorization. Alrighty, so there we go. There is our solutions, which means that there are two potential stationary, so there's two stationary points, x equals 3 and x equals 1, and now we need to test to see whether these are maximums or minimums. I like to do this just using a quick table. Alrighty, so we already know that the derivative at 0 and 1 and 3 are both 0, and now we just need to check the points around it. So that's 0 and 2 around 1, and 2 and 4 around 3. Alrighty, so you can see I've just worked out x equals 0, 2, and 4, the slopes at those points, and you can see that we've got positive slope, 0 slope, negative slope, 0 slope, positive slope, which means that x equals 1 is a max, and x equals 3 is a local minimum. So we've got our local maximum and local minimum. The question is, are these global or not? First thing to do, let's work out the y partners. So when x equals 1, y is equal to, alrighty. So the local maximum ends up being 1, 24, and the local minimum. And so our local minimum is 3, 20. So we've found our local maximum and our local minimum. The only thing we've got to check now is the endpoints. So for the function defined, the two endpoints are minus 1 and 4, so we just need to check those now. Now, we've got x equals minus 1 and x equals 4. Let's find out what y equals. Alrighty, so this point here is minus 1, 4, which is the global minimum so far. Just because it is actually smaller than our local minimum that we found earlier. Alrighty, let's check x equals 4 and x equals 4, the upper bound, we get 424, which is actually the same height as our previous maximum we found, 124. So let's put all of these points together. So if minus 1, 4 is the global minimum, and we also have that, we get that 320 is the local minimum. 424 is their global maximum. However, 124, they have the same y coordinate, is a local maximum, or it's a local and global maximum. Alrighty, so there we go. That is our final picture. Now, the best way to check something like this is to just sketch it quickly in your calculator and check that you got the global maximums and the minimums, and that the picture looks like what we imagine it to. Alrighty, I'll see you in the next one. Bye.